Sorry, can you hear me? Yes. Yes. Should we get started, or should we give 5 more minutes?
Yes, I think we can get started.
Okay, then we just slowly get started. Yes. So first of all, I would like to say welcome to everyone to this webinar, which is collaborate organized by CIGRE NGN, Romania and Denmark. And the title of this webinar is The Breaking Wave, Building Power, Future Offshore Wind Storage and P2X Solutions. And first of all, I will introduce a little bit about CIGRE and CIGRE NGN Denmark. And then our representative, Professor Floring, will represent Danish CIGRE NGA to make his presentation. And then afterwards, CIGRE NGA Romania will represent their organization. And then the representative of CIGRE NGA in Romania, so Sebastian, will make his presentation. Yes, so yeah, then we'll get started. So hi everyone, my name is Sia, and I am the CIGRE engineer member, and I am a high voltage electrical engineering, works in a company, Romanian Energy, which is a local Danish company that develop the onshore wind farms and other renewable power plants. And so sorry, I can see in the chat, anyone have some issues with hearing me? Okay, I think I will continue. If there's any issue, please raise your hand, because I have the presentation, so I can't see what's really going on. Yes. Yes, so to continue, so first, welcome to CIGRE. For those who don't know, that CIGRE is a global community for the collaborative development and sharing the power system expertise. And we are a non-profit organization established in Paris, France, back in 1921. And we are a key player in the development of the power system in a very long history. We produce the reference publications based on the practical experiences and the data. And we have an open, engaging, fact-based culture. And our aims is to connect in the power systems professions from all over the world. And CIGRE currently has 16 domains of work, and each of the work has a study committee. And these domains of works are categorized into 4 groups, based on the professions. So, for example, Group A is working on the equipment, and Group B is working on technologies, and Group C is working on the system, and Group D is working on the new materials and IT. And for sure that there's part of CIGRE that you can find your interest and that suit for your expertise. And yes, and CIGRE's community is spread across more than 90 countries and underpinned by 61 national communities. And each community is offering the members direct access to local events, services, and support. And for CIGRE NGA, so NGA is short for the Next Generation Network. And we represent for the new young professional and students under age 35 or less than 10 years career experiences. So we'll represent your gateway into the multifaceted world of CIGRE. So I would like to give a really short introduction about CIGRE Denmark, CIGRE NGO in Denmark. So we have currently over 160 members, and we kick off back in 2019, March. And since then, we have been really active in the globally, and we have several international collaborations with the different NGA committee in Norway, Finland, Italy, and also this webinar is also collaborate with the Romania NGA. If you want to know more about our activities, and you can find it in our Facebook page, a LinkedIn page, or also in our website, which you can see in the right corners. And for CIGRE Denmark, our work is based on so first at all, we represent the young engineers' need, and we drive the initiatives, and we also represent the young engineer in the national Danish CIGRE committee, and also in the international level. So we also participate in the CIGRE central office meeting, and we're also the most important that we create a platform for the NGM members for both networking and professional opportunities. And also we collaborate with other young engineers bodies, like, for example, IEEE and the ITE, etc. And I'll give a short introduction of our steering committee. So we are all volunteers. So our chair is Daniela, and she's also the key organizer to this event. And we also have a vice chair, Gustavo, and the secretary, Leonard. And other than that, we don't have a fixed role. So we just we will organize different events. Yeah, and we are with different backgrounds. Some of us are working in the university, and some of us are from the industry. Yes, and there's 2 events in the pipeline for 2024. There's one technical visit to one of Eurowind's Eurowin Energy's hydropower plant, which is also collaborate with the Aalborg University, and this might take place in September 2024. And please follow us on the social media for the dates and more details. And there will also be an annual general meeting for the CIGRE NGO member in Denmark, which will take place in DTU Lundby. The date and details will be also published later. Yes, and CIGRE Denmark will also attend the Paris session in 2024. So the Paris session will be in August. And for those who want to be participate in the Paris section, please notice, because there's both Tour de France and Olympics Games will takes place in Paris. So please book your trip in advance. And yeah, and for the Danish CIGRE NGO members, there are 2 papers have been accepted, so they will be participate in the NGO showcase. And we also have 2 more free registrations as a CIGRE NGO members, and please contact us if you're a Danish member, or contact Romania steering committee if you're a Romanian member for the free registrations if you are interested in participating. And later, so next year, 2025, NGA Denmark will also be attend the symposium by the Nordic Region CIGRE Council, which will take place in Norway, and we funded the NGM panels, and we also have a reception together with Women in Energy, and notice that the call for paper will will probably happen in the autumn, and the dates will also release later. Yeah, this year. And lastly, I would like to highlight the volume of benefits that CIGRE membership can deliver to you. So first of all, you will be always prepared for the future keychain innovations and challenges, and you will also learn the experiences, lessons from real world, and you can always make your decisions with the diverse global perspective. And we always collaborate with the both local and international. So there's also an international platform, and you can also, because the collaboration is also really close with the local organizations, so you can always address your challenge to the local. And also as a student, you have free membership, remember, so you can always have access to the CIGRE publication for free. Yes, and overall that you can also connect with your from your academic experiences to the industry technical based setting. Yes, and thank you so much for and if you have any question and suggestion, you feel free to contact me. And then I will give the presentation to our Danish NGA representative, Professor Flory. Thank you, Flory.
Okay, thanks a lot for having me in this event. Let me share my slides. When I was doing the slides for this event, I was realizing for how long I was in this business, about 30 years. And it was quite funny because I dig up some of my old slides from 2002, 2003 to look into some of the aspects. But I will give you a short overview of the technologies in the last 20 years, as far as I saw it. Something about renewable energy in Denmark as it was in the last years. Grid codes, and this is quite a nice timeline, at least for Denmark, and this is linked also to what was happening into Europe and world in the last years. Something about the grid support markets, future developments as we see them here from this side, something about security of supply and actually the electricity infrastructure, the cables. And I will end up with briefly some comments about the new requirements for hybrid power plants, which were just launched as a draft here from our side. What we saw in the last more than 30 years, wind turbines going from couple of kilowatt back in 80s to 15, 16 megawatt these days of offshore ones. On the PV side, it was kilowatt system back in 2010. It was quite a good business at that time to buy some PV and put it on your rooftop and then earn some nice money. But then everything changed when all this went to the actual market, spot prices, and right now there is no business case to actually put your PV panels on the roof and try to earn some money. And then back in 2017, it was, at least in Denmark, commissioned the largest PV plant, 61 megawatt on Sjælland, and then now more is coming. As a state of the art right now, we see these converters of 250, maybe 300 kilowatt that will have multiple DC to DC stages with strings and so on. Sunny Central from SMA, it's about 2.5 megawatt, but there is some trade-off here, how much power you have on the AC side and how many DC to DC converters you have for the strings. In Denmark, back in 2000, I found some slides. It was about 500 megawatt wind. Now we have almost 7.5. On the PV, as I mentioned, until 2012, it was not too much. The biggest capacity started to be seen into the grid from 2017, and quite a large increase in 2022, where at least 1.3 gigawatt large PV packs were added into the grid. Just as a number, in 2023, about 63% of the electricity supply came from solar and wind. And we can notice also on the maps back in 2017, maybe it was a lot of wind power offshore, not too much onshore, while I saw it on the landscape, quite a lot of new megawatt wind turbine onshore growing up in all the places. On the grid code side, this is quite nicely because I realized that everything started maybe from the high voltage grid and then went down to the medium low voltage, and now is going back to the high power grid. Before 2000, I will say that the main focus was in the low voltage, medium voltage, because of the wind turbines being quite small, and it was mainly power quality. Then in 2000, in the grid code, it was only for the large wind parks. They were talking about production limit, operation over under frequencies, and they were asking to have reactive power, to have a unity power factor in the point of connection. Somewhere in 2001, Germans came with the fault right-through down to 0, and that, keep in mind, it was one of the triggers that we saw it also in 2004 in the Danish grid code, where they were putting low voltage right through, and then for the large wind farms, they were talking about active power control, as we see it now as standard in every wind power plant, with some priorities, a frequency control, a reactive power control, and at that time they were starting to talk also about models to verify the power system stability in those tools used by the TSO. Somewhere in 2010, it was an update, and they were talking about a frequency control for wind power plants bigger than 25 megawatt. And then low voltage right through with reactive current support for whatever was wind turbine more than 1.5 megawatt. The grid code for the PV came actually in 2014. At that time, they were, I will say, copy-paste whatever it was on the wind and put it on the PV. But the focus was on the PV systems more than 11 kilowatt. They were defining the types of the plants, A, B, C, and D. They were talking about low voltage right through for large one, more than 25 megawatt, reactive current support also during the fault, and then all these active power control and priorities that we saw it in the wind turbine. In that time, 2010, 2012, as I said, there were quite many people buying PV systems on the top of the roof. And then most of the DSOs at that time, and there were quite many, they started to get complaints about the power quality because it was cheap PV systems from China, not too grid friendly, I will say. And then 2016, the ENSOE came with the RFG 1.0, and that was one of the turning points. Why? Because before that one, every country, at least in Europe, had their own ways to specify grid connection requirements. It was challenging for OEMs to define unified product specs for all the markets. And typically quite large teams were monitoring all the grid codes within those markets where they have focus. And then it was challenging to put all those specs in their list of specs for the wind turbines and also for the plant control. After that one, it was very nice because we got some clear definition, how to specify stuff, how to ask. And then in 2017, I will say, the Danish grid code, I will say 1718, it was updated for the wind and solar, and then in 17 they came also with the grid codes for energy storage batteries, and they were asking at that time LFSM over and under, frequency control, absolute power limit, power gradient, reactive power factor, and voltage control. Somewhere in 18, they came with the models for loads, quite details. In 19, they came with very clear specs for all the markets, FFR, FCR, automatic FRR, and manual. Just as a short break here, somewhere in 2010, some of the TSOs in Europe were talking to have inertial response into their grid code. Then after talks with the OEMs, they say, okay, we cannot ask right now. We will leave this for the market. And actually, FFR is that inertia response that you see it in quite many papers back in 2010-14. And keep in mind that grid codes, it's about compliance and not about additional revenue. If you comply, you can put your unit plant. Otherwise, you don't have any business case. In the last 2 years, I will say, we got the grid code for demand connection for the high voltage grid. They are talking about FCR, automatic FRR, and so on, but it's still in the draft. It's pending, at least from the Danish side, to be published. And then mid-April, we got this draft for the grid codes for co-located overplanted plants. Also, it was an update on the energy storage, and then a new set of tender conditions for the grid support services. As I said, in the last 2 years, quite a lot was happening, at least on the service market. they moved to this Nordic automatic FRR capacity market. They changed the imbalance settlement period to 15 minutes. They were joining last year the Nordic manual FRR, and then this year, these days, they will move to 15 minutes ISP and IDC, also joining the those platforms Mari and Picasso. What will happen in the next couple of years, we don't know yet. In the news here, it was stated quite clearly, and also part of the Danish policy, that green energy from solar and wind must be 4 times as it is now by 2030. This means about 36 gigawatt in the next, I would say, 6 years or less. They put also on the map some places for the future energy parks. It's about 32 parks, which are mainly wind and solar. Some local players, they put on the news about joint partnerships, 15 energy parks by 2028, in total about 2 gigawatt peak. Some of the players on the battery market, they started to put quite a lot of money to be part of the game with large scale utility batteries. And then in April 2024, so last month, more or less, it was announced the tender for 6 gigawatt offshore wind power that should be completed by 2030. So a lot is to come in the next years. And then this is also linked to the Danish green transition, aiming to have this P2X carbon capture, cross-sector coupling, and so on. According to the target, we need to have at least 6 gigawatt electrolyzer plants by 2030. Last year, it was launched this 300 megawatt solar and electrolyzer and methanol plant, P2X plant, which is more or less up and running. And then on this side, everybody is talking about the electrification of district heating, harbors. Everything should be electric based on wind and solar. Now, we can have this, but we still need to talk about security of supply. Every year in February, I'm taking some screenshot from Energinet webpage to monitor what is coming from wind, solar, what are the loads, and so on. And this is what I captured at least for the 2021 and also last year. I have also the data for 24. Right now, I need to add it. The main point is that renewable energy, it's quite volatile. You have a high mismatch between production and demand. And always there is a high penalty for the energy providers if they don't match the bids. And end of the day, it's about keeping the balance between demand and power supply. Means that ideally grid frequency should be 50 hertz, not too much or too less. Energinet have some prediction for 2040, and clearly the power grid will be overloaded. They identify some areas which lines will be overloaded, and this is linked to these new parks that will come, new P2X plants, new offshore, and so on. And they have also some list of what should be developed and also which kind of solution they should follow. And then to build new lines, at least here is not a quite good option in short term, because there is a lot of time to get public acceptance for the new lines, where to put them, where not to disturb the view. And it's very time. So you cannot build it in a couple of years. You need quite a long time to make these new lines. And then what Energinet found is that they will go maybe for the market option, which means co-location. And this is why they came with the draft last month, middle last month. Right now, there are ongoing discussion with the actors, stakeholders. The aim is to be finalized and published by the end of this year, so that they will be able to launch the tender for large P2X plant. So it's quite a pressure here to have this grid code ready by the end of the year. And then what they are asking, just a couple of points here. I will not stay on this page. I will say the most important will be this one, because they are talking about one single point of connection where they want to have the grid code compliance. This may be valid also if you have a DC system in your hybrid plant. And also quite important, they want to talk just with one legal person about the grid compliance and so on. I think right now that might be several actors that will build such a hybrid plant, and then who will be actually responsible for the grid compliance in that point. And this is why Energinet wants to have just one person which will take care of this. In the draft, they talk about faults, abnormal events, withstand capability, power control, control capability, power quality as usual, and then how to operate and monitor, and also about models, which is not clear right now what they will ask. We know what is about wind turbine, wind power plant, we know the PV, the batteries, but how about the rest? On the fault side, I would say that what they are asking is quite tricky, and I will tell you why. And then for the first time, I see this POD, which is nice. It was on the research side for at least 14 years, but I still think that this is not feasible as long as you don't have clear rules on how to prove that you are giving that kind of service, and also which kind of grid eigenvalues you need to dump. When we talk about the grid codes, they have these two cases. They show us in the first meeting what they are thinking, how you should react with your hybrid plant if you have a voltage down to, let's say, close to 0.2 per unit, the red line here. But what they are talking and what is written there is not really clear from the controller point of view what you should do with your plant in order to do this, especially if you have electrolyzer. Can I cut the entire plant or not? Should I mention, should I take care only with the wind, or if I have the PV, and so on? post-fault is also one quite tough demand, I will say, because they are asking based on what is your plant status, if you import power or if you export power, to comply with two different kind of rules. And this is a left and right picture. And then if you look at the number, T2 in both, it's quite fast. So if you have, let's say, an electrolyzer plant, which may have quite a long time to ramp up after a fault, I'm not sure how you will be able to do this, but yeah, it's something open. Just to close all this, I will say that Denmark was always a pioneer within renewables, wind, and so on, and also cross-sector coupling, integrated energy systems. Typically, as far as I saw it in the last years, the grid code developments are showing the current or the new future penetration level for renewable or loads. As I mentioned, new grid codes for coal located over planting plants will be challenging. Based on what I'm hearing right now, electrolyzer technology are not yet ready to cope with the integration into large plants. Some technology might be quite slow. Developments of controls and coordination at, let's say, system user level will be challenging because of different response time from assets and also for the park modules. We can talk about different communication technologies, protocols which are not unified, and we can talk always about what is here. On the grid code compliance will be about testing. You have the unit, you have the park module, you have the entire plant. What is the order, what you should prove, which kind of test you need to do, and all these guidelines are right now not clear. I would say may come. And then it will be a big unknown about the models, because we don't have yet models for electrolyzers. On the academia side, we are still working to get some useful models for this that will account the actual behavior for the startup, for the shutdown, if it is cold or not, how you ramp it up, and so on. And this may take time to get these models. Finally, I would like to draw your attention on this IEA TCP Wind Task 50 hybrid power plants. We have international participation from industry, academia. NRL from US is actually leading the task. The overall aim is to provide definitions, guidance, and so on, and also to develop some models that eventually will go to the standardization. In particular, the work package 4, dealing with electrical design, control, grid support, is led by the Danish team. We have DTU, Aarhus, Aalborg, and some companies in this team. We have two ongoing stuff right now. A report on the interoperability aspects of hybrid power plants. And if you would like to be part of it, send me a mail. And then we are working also with a larger team on this report and also model for the open source model for utility scale HPP control. It will not be only the control part, it will be also the wind park module, the PV energy storage. Unfortunately, in this round, we will not have electrolyzer. We need to have a cut, but maybe in the next run, we will take it. If you want to be part of this, you can contact my colleague from DTU, Kaushik. So that was from my side.
Thank you,
Hopefully I
Florin.
was in the time.
Yes, that's perfect. Thank you for your presentation. And please, if anyone has any question to Professor Florin, please. If there's no question, then or if you need time to think about it a little bit, it's also fine. Then we can take in the end. And then Anna Maria, please.
Thank you very much. Thank you, Mr. Florin, for your very interesting presentation. I will say also again, if there are questions, please feel free to use the chat. Also, at the end of the presentations, we will have a session for Q&A, and we will take all the questions for both of our speakers. Let me introduce myself, and in the meantime, I will share my presentation also. My name is Ana Maria Iamandi. Okay, now you should see my screen and my presentation. My name is Ana Maria Iamandi. I'm the General Secretary of CIGRE Engine Romania, and also representative of CIGRE Engine IAC. And I'm also a protection system specialist. I'm working at the National Dispatch Center at the Romanian Power Grid Company, which is Transelectrica. Regarding our committee, CIGRE Engine Romania was founded in 2015, sorry, at the initiative of our former chair, Mihai Marcolț, after attending the CIGRE Paris Engine booth. Since then, we have 65 members. Most of them are young professional engineers between 25 and 30 years old, and there are from all areas of energy sectors. Regarding gender balance, we are very glad and in the same time very proud, because as you can see from the chart, we are approximately equal distributed. Regarding our interest and our activities, the main focus is to follow the CIGRE Engine IAC vision and to increase the expertise of young engineers in the field of power system. How does the CIGRE Romania do this? So we are organizing different events, technical visits, expert talks, technical seminars, webinars, roundtables, and we are involving as much as we can the young engineer. In the following slide, we will present this event more detailed. We will start by presenting the activities of NGN Romania with 2022, because in that year the board of our NGN was changed, and we created new project concepts, new partnerships with the energy sectors from Romania and also from the CIGRE world in order to develop the program. Main activities that we carried out was the webinars, workshops. We had a webinar organized with our colleagues from France called Clean Technologies and Energy Storage. We had another workshop called CIGRE, the first 100 years and the role of young professional in the energy transition. The aim of that workshop was to familiarize the Indian Romanian members with CIGRE history, the concept, the activity of national and also at the international level, and to familiarize them with opportunities that CIGRE offers them. Also in that year, we had the conference called the Regional Southeast European Conference, organized by our national committee. We contributed to the organization of the event, and also during that event was an scientific paper competition for young professionals. We will speak about this conference and about this competition more detail in the following slides, because this is a biennial conference and this year will take place again. In 2023, we continue to develop the project that we initiated in the previous year, and we founded a coordination committee formed by a team committee, by an event committee, and also by a scientific committee. Therefore, we could increase the frequency of the event, and of course, the number of the members also increased. In 2023, we had another conference organized also by our Romanian committee called Conditional Monitoring, Diagnosis and Maintenance. During that conference, we, as a NGN, organized a roundtable dedicated to young professionals. The roundtable was called Next Generation Vision for the Future of Energy System. We had another collaborative webinar organized with our colleagues from France called Power Grid Resilience to HVDC Technology, and two technical seminars called Expert Talks, one called Design and Construction of Overhead Protection Line, and the other one was about the resilience of the power system. We also organized technical visits. We had a technical visit at the thermal power plant and also at the power substation through which the power is evacuated in the power system. These are located in close proximity of Bucharest. And we participated at the CER conference in Istanbul with papers and also at the roundtable organized there. A part of these main activities, we are involved in different collaborative activities with the student association, future energy leaders, and so on. This year, we started a new project organized by our NGN CIGRE. First is Pathway to Power interviews, where we talk with young professionals with notable achievements in energy field. We already are on the third episode. You can watch them on our YouTube channel. And the other one is our first digital mega sign called Volta. This is realized under the coordination of our national committee. Regarding our agenda, we already had the technical visit at the hydroelectric power plant located on the border with Serbia. Our current webinar. On the short agenda, we have next week a technical seminar called in which we will learn about the electricity market. Then we will have a technical visit to underground power station that belonging to Bucharest subway. Then the power station will participate there, and we'll hope to physically meet as many as you as possible. And at the end of the year, we will have a conference very dear for us, the Regional Southeast European Conference that I will speak a little bit before about this conference. This conference this year will take place in Timișoara in Romania in October. The main focus of the conference is to promote young engineer. Now the conference is at the 7th edition. As I said, it's a biennial event dedicated to young engineering. And also this year we are on the 4th edition of the contest, the scientific paper contest. Which is dedicated to young professionals, to students, and we will have prizes summing to up to $2,000. So we are strongly encourage you to participate. As it's a conference dedicated for young engineer, we have a lot of activities dedicated for NGN members. A part of the contest will have also a forum. If you want to participate at the forum, please let us know. We are very glad to have you there. We will have a special NGN social event. And also we'll organize a technical seminar, another edition for CIGRE Expert Talks. Also, if you want to participate, please let us know. Thank you for your attention. Following, we are kindly asked to scan the QR code and to keep updated with our latest activity. Also here you will find the web with the site where the site of the conference, where we'll see more detail about RSEC, the topics for the conference, and also the important deadlines that it's good to have them in mind. In the following, Mr. Sebastian will present about large battery energy storage solution in Romania and also Europe aim to increase the stability and renewable installations. As you can see from already seen from the promotional post, and Mr. Enache has more than 14 years of experience in wind industry consultancy and company management, and is the business also the business development manager at Monsson Group, which is the biggest renewable developer in Romania. So, Mr. Sebastian, I kindly ask you to take the floor. I will stop sharing my screen now.
Thank you, Ana Maria. Hello, everybody. I hope you can hear me and see me well. In the couple of minutes that I have, I will not try to bore you. I will try to tell you interesting stuff about what we're doing. Indeed, I've been involved in the renewable energy sector in Romania in the last 15 years. I've been the one that tried to introduce renewables into the grid. I've been and we've been the first company in Romania going to the national TSO and the national dispatch center, trying to figure out a way how to securely connect and operate renewables into the grid. As a very short story, I remember that in 2004, when we first started, we connected the first turbines, so we had to be very transparent and to have very good communication with the TSO. And since the beginning, we thought about installing storage. At that time, storage was, as technology, in early stages of development, was also very expensive and was also not so technologically advanced that could be integrated with renewables. I will try to share my screen, and please confirm if you see. Okay, I'm trying to. Can you see my screen?
Yes, yes, we can see.
Okay, okay. So just a short story to understand the necessity and the driver that we had. We've been seeing the developments in the renewables and the grid into renewables in Romania. From the beginning, we were not only developers, but we were also operators, and we've always encountered the problem on the producer side, that we felt that we had to sell and to produce energy not so unpredictable. The forecast was not going very well, and we always had a problem in communicating the production to the grid in order to have as low imbalances as possible. So after 15 years of developing a lot of renewables in Romania, after 15 years of operating more than 10,000 megawatts in Europe, and with a lot of efforts, we decided that it's important to have our own investment in storage. Right now, the legislation in Romania is allowing renewable energy producers, both wind or PV, to connect to the grid, to act as hybrid power plants, and to install behind the meter energy storage systems and adapt to the legislation and to adapt to the necessity of the grid, and to have a stable power. What I would like to show you now is actually the system that we've recently launched. If you see in this presentation now, we have this hybrid power plant that is not under construction, it's actually in operation. So we have two PV plants, one PV plant of 35 and one PV plant of 7.5 megawatts. We have one wind farm of 50 megawatts, and we have a storage unit of 216 megawatts by 4 hours. Right now, we have commissioned the first 24 megawatt hour energy storage solution, and two 48 by 2 hour megawatt storage solutions are under construction. I would like to share a movie with you. So if you could, please, I would like the organizers to support me. I will stop sharing, and maybe we can see the movie and then continue again. Daniela, if you can help me. Thank you. So I will present now the 24 megawatt storage solution.
Astăzi, cred că este chiar un moment istoric.
This is Mireasa wind farm, 50 megawatts, and together with Prime, we've built, I think, a very interesting solution. Storage filled with water.
Bună ziua și bine ați venit! Și împreună sper să avem o zi plină de vânt, de soare, energie pe care să o stocăm în baterii. Cel mai important lucru, zicem noi, pe care l-am făcut până acum, sistemul integrat hibrid de la Mireasa, pe care îl veți cunoaște mult mai bine astăzi, format din energie regenerabilă produsă din parc eolian, parc fotovoltaic și o instalație de baterii din perspectiva noastră unică în Europa.
Au fost necesare aproximativ 4200 de ore de inginerie pe parte de electrică, 3000 de ore de inginerie pe parte de mecanică. Inginerie care cu mândrie spune că a fost realizată în România, în București și în Constanța, alături de colegii de la Monsson.
Mă bucur foarte mult că avem oportunitatea să inaugurăm cu specialiști din domeniul energetic acest proiect.
Pentru Comuna Siliștea, grupul de firme Monsson este cel mai mare investitor.
Capacitățile acestea de stocare generează o stabilitate în sistemul național energetic. Vă felicit!
Astfel de tehnologii trebuie sprijinite de către noi toți ca români.
Un lucru important este că reușim cu componente românești și europene să fim competitivi, să avem prețuri bune, să venim cu o soluție care poate fi implementată, să fie bancabilă și solvabilă.
În primul rând, felicitări pentru proiectul acesta românesc. Eu cred că este foarte important și sunt niște cuvinte care ar vrea să rămână întipărite în mintea tuturor. Și felicitări celor de la Prime că au investit și au crezut în baterii și în faptul că acesta este o soluție a viitorului. O soluție pe care noi o gândim nu doar pentru noi, ci și pentru copiii noștri.
În acest moment este cel mai mare proiect de baterie de stocare instalat și produs în Europa.
Va realiza acel echilibru de sistem în România și va fi un exemplu pentru toți ceilalți.
Să-i felicit pe cei care au realizat acest proiect pe Monsson, un pionier al sustenabilității. Cred că este chiar un moment istoric.
Primul de tot este adevărat.
Thank you very much, Daniela. I will try to Can you see the screen now again?
Yes.
Okay. So this is the location where the movie was, and I will give you some general details about the storage solution. We've designed and we've put into 400 square meters for 24 megawatt hour. And our solution, it's actually interesting because we wanted to have a 100% European technology solution. So actually the batteries are produced in Romania and the automation in Europe, the engineering in Romania, and the software solution to control the battery system, to control and to hybridize wind, PV and batteries are produced by Monsson with local software engineers. So we wanted to put in 400 square meters, 24 megawatt hours of battery, and we will build one by one up to 216 megawatts hour until end of this year, probably maximum January, February next year. This is the solution that I will present today. I will briefly present the technology. The technology is with lithium-ion batteries produced by Prime and water-cooled. The solution can integrate actually any type of battery that is water-cooled. We would like to implement these projects not only in Romania, we are discussing with different developers and owners that want to integrate our water cooling technology and management system and battery management system with different batteries produced either in Poland or Sweden, like Norvolt. So we wanted not to be battery dependent and for the owners to be able to adapt their technology and introduce as much as possible local technology for this. We are right now under patent. This technology and the water cooling technology of the storage solution is keeping the batteries at 18 degrees, winter and summer, and this allows to have around less than 1% own consumption for the heating and cooling for the batteries, increasing the efficiency of the storage system. We are monitoring very thoroughly the temperature. We have sensors everywhere, and we have 3 different fire prevention systems. From our point of view, the solution that we've tested, we've introduced as a pilot, and now we are building at large scale, is a very volatile, a very secure solution. And as you know, the most important thing in a storage solution are not only the batteries, but also the way you cool the batteries and how much the consumption of cooling the batteries is. So I think on this we've achieved a lot. Together with the battery storage system, we are introducing and we are promoting energy storage courses. So Romania, I think, is one of the leading countries in introducing new employees into renewables. I would also like to touch this topic because we see a lot of renewables develop, wind, PV and storage, and a lot of people coming from other industries towards renewables. So from our point of view, reskilling and upskilling of employees is very important. If in Romania in 2004 we had up to 500 people working in renewables, I can tell you that right now in Romania there are at least 50,000 people working in renewables, and we estimate in production, energy production, wind and PV. Romania and the Romanian government and the Romanian TSO wants to install up to 2,000 to 3,000 megawatts hour of batteries. So from our point of view, an additional 5,000 people will need to be trained into energy management systems, hybridization, energy producing, and also operation and maintenance of energy storage systems. This is something very important, and without trained people, we think it's very hard to move forward. Right now, the Romanian system has a lack of energy consumption, and this is why the overproduction is important to be stored in the storage systems. If you have additional questions, if you have anything, please let me know. I think the most interesting part was the movie, and I just wanted to give you some minimum technical information. If you have any additional questions, please use the Q&A session. I would like to thank you very much for your patience, and I hope that I also had the 15 minutes that I was allowed to. Thank you very much.
Thank you also. Very nice presentation, and also the video, very, very interesting. We are very proud that is a Romanian project.
Everybody is invited from this call to visit. So if you want to organize an international CIGRE visit or anything, please feel free to organize, because we can do organized trips on this.
Thank you very much. Thank you very much. For sure, for us is it will be very nice to see. Thank you.
It's 20 kilometers away from the Black Sea, and it's summer, so
it should be in a weekend to take advantage for the location. Okay, thank you. I kindly ask the participant to feel free to ask the question, thoughts, curiosities.
Yes, I think there's one question in the chat by Wendy.
Okay.
I think this question was for Professor Florin. Yes, and the question is, do you consider
It is.
yes.
It is part of the up or down, depending on how you want to play with the renewable, but also with the loads into your hybrid plant.
Yes, and I think Debasher raised her hand.
Yes, but I don't know if...
Hello?
Hi.
Hi, thank you to both the speakers. My question is for both the speakers regarding, is there a limit to the BESS capacity in the hybrid power plants? Because they can act as dispatchable loads as well. So is there any specific limit that the BESS in the HPP cannot go beyond a certain capacity?
Please.
So maybe I can start on this topic. Usually there is a cost-benefit calculation. You can install as much capacity as you can. Nevertheless, you need to calculate the time that you need to charge the batteries, how long you need to keep the energy into the batteries, and also the discharging time. In the renewables industry, in order to integrate storage with wind or PV, usually we calculate around 20% by 4 hours. And this is sufficient enough to charge and discharge and have a viable business case. It's not, let's say, industry standard, but at least right now, this is the capacity that we see. It makes sense in order to have the capex low enough to support the let's say the investment, and to have a sufficient IRR, and to play with the energy on the day-ahead market, or to make balancing, load shifting, and also you can adapt the commercial strategy based on the energy prices. If we speak about behind-the-meter batteries introduced in wind and PV power plants. If we are speaking about standalone batteries, the discussion is much more wider, but usually, at least what we've seen in Romania and into the grid, probably 50 megawatts by 2 or by 4 hours should be sufficient for a standalone battery to make a business case.
May I comment? Keep in mind that it's 6,000 times more expensive to store energy than to produce it. It's quite a large levelized cost for the storage compared with wind and PV. In Denmark, some of the players are putting batteries to go for the FCR market or automatic FRR market, but the business case here is not valid for energy arbitrage, that it's out of scope here.
Thank you so much.
Any other question from the audience? Please don't be shy. But in case
they can send the Q&A via email if necessary.
Exactly. Perfect. So as Sebastian said, feel free to ask questions now that you have seen their emails. We will come back as CIGRE and GN. We will come back with the presentations and with the recording of this webinar. So if nothing else, maybe we can finish a little early. I would like to thank all of the speakers, especially Florian and Sebastian that were our guests. And yeah, thank you so much for today.
Thank you.
Thank you.
It was a pleasure. See you soon.
Thank you, everyone.
Likewise.
Thank you very much for your support and we have a question from Alexandru. I saw the hand raised.
Me too, but I think he left the meeting.
I think it was a mistake. Yeah.
Okay.
Maybe. Yeah. Okay.
Yeah.
Okay.
Thank you, everyone.
Thank you very much
Bye.
for
Thank
the
you.
support and for
Bye.
having this webinar. Bye.